Okay, now if you're wondering why we've skipped over a bunch of stuff, remember I said we weren't going to do anything with frustums. So if you're looking at the notes, you see all these things on frustums of a cone, just skip over that. That includes skipping example 2, and we're going to go right to example 3, which is an application of being able to find either lateral area, surface area, or volume of a cone, and maybe possibly other figures we've talked about in this chapter. Now, ladies and gentlemen, the thing is, when you do an application problem, the first thing you have to understand is what shapes are you dealing with. Secondly, what measurement are we finding? Do we have to find lateral area? Do we have to find surface area? Or is this a volume problem? Remember, if you're covering something up, if you're painting something, wrapping something, that's usually lateral area, surface area. If you're filling the object up, that is volume. And a lot of times, ladies and gentlemen, if you look at if you're having to do a conversion, look at the label. You notice this inches cubed here. That probably gives away that this is going to be a volume problem because you have a volume unit of measurement in your label. So it says find the weight, and anytime you're finding weight, that is a volume of the cast iron shape below at 26/100ths of a pound per cubic inch. Round your answer to the nearest pound. So let's take a look at, first of all, at what figures we're dealing with here. And it looks like we're dealing with two different figures. The top of this cast iron shape, which means it's probably pretty heavy, is a cone. And then the bottom of it looks to be a cylinder. Okay? So the two figures we're dealing with are a cone. All right, let me kind of write it in the same color as I got it up there. We're looking at a cone, and we're also looking at a cylinder. Now, what are we going to do with those? We're going to find volume because we want the weight of it. So probably we're going to take the volume of the cone plus the volume of the cylinder and get the total volume of that entire object. Then we'll have to do a conversion to get it over to pounds so we can measure the weight. So let's start first of all with the cylinder, okay? Let's start with the cylinder. Now, if you remember volume of a cylinder, if you look on your formula sheet, volume is just basically equal to the area of the base times the height of the cylinder, but your formula sheet goes into a little bit more depth. For area of the base, it's pi r squared times the height. Now, what are we given here? Okay, we're given, it looks like, the diameter of the base. So if we're going to use radius, we've got to cut that in half. So the radius would be 5, and that's inches. Diameter would be 10 inches. This is the height right here. The 13 is the height of the cylinder, and it looks like 6 is the height of the cone. So this is the height of the cylinder. This is the height of the cone. All right? Height of the cylinder, height of the cone. Okay? Don't add those together because we're looking at each of these individually. So, if you do this, ladies and gentlemen, to find volume, and again, it doesn't tell us what we can use for pi, so you can either use the pi button on your calculator or just use 3.14. We're going to take that times the radius, which is 5 squared, times the height of the cylinder, which is 13. And if we do that, we get, and I'm not going to round it too far, and I did these calculations ahead of time, so I don't know if I even have to round this at all right now. But I get 1,021 and 2/100ths of a cubic inch. Because remember, this is a volume, right? Now let's do the same thing for the cone. Let's find its volume. If you remember, volume was equal to 1/3 area of the base times the height. Or you can just say 1/3 area of the base, again, is pi r squared, times the height of the cone. All right? So, volume is equal to, just fill in 1/3 pi, the radius of the base. Well, it's going to be the same as the radius of the base of the cylinder. So again, this radius right here would just be 5 inches. That'd be your radius for the base of the cone because it's the same as the base of the cylinder. And take that times, so again, that's going to be pi, 1/3 pi, times 5 squared. Now times the height of the cone. The height of the cone, remember, was 6 inches. All right? So if we do that, get all those and working together, and again, it's about 157.08 inches cubed. Now again, how do we find the total volume? Well, we're going to take and add the volume of the cylinder plus the volume of the cone. So to find the total volume, we're just going to take volume of the cylinder plus volume of the cone. And if you do that, you get 1,178 and 1/10 of a cubic inch. Now, again, it wants weight. It said, find the weight, and then round to your answer to the nearest pound. So we're going to have to do a conversion because this answer right here is in cubic inches. It's actually a volume. So if we do a little bit of our railroad method here, we got 1,178.1 cubic inches. According to what we were previously given, that it's 26 hundredths of a pound per cubic inch. So right away, those are going to cancel out. And then you just multiply across. You take your 1,178.1 times your 26 hundredths, and that's also going to give you a label of pounds. So if we do that, I think you get exactly, and I may be wrong on this, 306 pounds. Okay? I don't think it's going to be exact. Let me just quick look. Let me do the calculation here. If you take 1178.1 times 0.26, you get 306.306. And again, if we're going to round that to the nearest pound, then your answer is going to be, that thing's going to weigh, it weighs a lot, 306 pounds. All right? So I hope that helps you out. If you have any questions on the application so forth, let me know. But here's the assignment, depending on the type of book you have. If you've got the white book, you're going to go to page 595 to 596. These right here are A and C are just cone problems, which you're given certain dimensions of the cone. You have to find either lateral area, surface area, or volume. And these are the application problems. I gave you 4 of them, so read those carefully. If you're in the blue book, it's just different pages, but the same problems. And I've also, if you don't have your book, I have attached in Google Classroom, blue book practice exercises, which are just page 620 and 621 out of the blue book, so you can do those. All right? Show your work, and if you have any questions, let me know. Have a good day, stay safe, and stay healthy.